When you go through your examples in the t-tests self-assessment exercise, you'll find that for some of the t-tests you find significant results, and for other t-tests you find the results aren't significant, even though there are differences between the things that you're comparing. So there are two possible reasons why we're failing to get a significant result. The first one is that there really isn't any difference between the two things that you're comparing, and that any differences that you have picked up could be just put down to random chance. However, there's another reason why two samples which are being compared may seem to be different, and that is that your test is just not powerful enough to pick up the differences that are there. So I want to talk now about power of a test. What is power of a test? How do we work it out? How can we improve the power of a test? And to do that, I'm going to have a look at my starting point at a previous histogram that we drew up. This is a histogram of the means of samples of 10 taken from the control population. So you should be very familiar with this by this stage. We have an average value of 120, and based on the standard deviation of this distribution, the standard error of a distribution of sample means, we're able to put a red line on the histogram at 1.65 standard errors away from the mean value to cut off 5% in the tail of the distribution. And I said that we compared this against our real sample value, which was 110 millimeters of mercury. And you can see that the blue line there, this value of 110 millimeters of mercury for our treatment, our drug, is actually lower than the red line, and therefore can be considered to be statistically significant. But what I've done here is really quite a shortcut in terms of statistical comparisons. You can see here that when I take 1,000 samples of 10 from my control population, that I get a nice smooth bell-shaped curve. And by some remarkable coincidence, it seems that I've actually hit upon an absolute value of 110 for the control population. Sorry, for the drug population which I'm comparing it to. The truth is that just as we have variation in the individual values for our control population, which is giving us the variation that we can see here in our distribution of means for the control, that there is similar variation for our drug population. So we would expect to find a similar kind of bell-shaped curve for the drug population centered on the average effect of the drug. So if you shifted that histogram so that instead of being centered where it is at the moment on 120, you slide it over so that it's actually centered on the blue line there, you get some idea of what I'm talking about. Now it's not possible to do this in SPSS, but I can do it in Excel and show you what the values would actually look like.